Assalamualaikum and hello everyone. Welcome to the video for Chapter 4, Introduction to Organic Chemistry for 4.6, Basic Reactions in Organic Compounds. In this video, what we're going to learn to explain covalent bond cleavage, which is homolytic cleavage and heterolytic cleavage, describe free radical and carbocation, and last but not least, to explain the stability of free radical and carbocation. The name of the subtopic is Basic Reactions in Organic Compound. So here it mentioned that all chemical reactions involve the breaking and the formation of new bonds, where the breaking of chemical bond is called cleavage. Okay, again, cleavage is the breaking of chemical bond. Okay, so for the cleavage, it is divided into two, which is homolytic cleavage and heterolytic cleavage. Okay, first we're going to look at for the case of homolytic cleavage. Homolytic cleavage is where two shared electrons of the covalent bond or the bonding electrons are split equally between two atoms. It occurs in a non-polar bond involving atoms of similar electronegativity. Usually when we're talking atoms with the similar electronegativity, actually it means it involving between these similar atom. For example, we have bond between chlorine and chlorine, between bromine and bromine, between oxygen and oxygen, or between carbon and carbon. Okay, again, each of the atom itself has its own value of electronegativity. So when we mention that the atoms have similar electronegativity, it means that the atom is the same. Okay, so what happened here? So here, let us look. Based on this specific example, we have chlorine and chlorine. So between these two chlorine here, we actually have two electron. Okay, remember that for one bond, we have two electron. So when in undergo homolytic cleavage, the electron are being split equally. One chlorine will have one electron, the second chlorine will have the second electron. So when it is being split equally, so it means that each atom contain take one electron, so that's why we use half-headed arrow, where one electron is being transferred. The product of the homolytic cleavage is called as free radicals. So here I'm going to write down free radicals are formed. For the case of homolytic cleavage, usually we will use UV. Okay, so for this one, X here, it means usually when we're talking about X, it could be any of the halogen, for example, fluorine, chlorine, bromine, iodine, or we could also use any other atom where these two must be the same atom itself. So it could be any carbon, it could be oxygen, or etc. Okay, so that is for homolytic cleavage. Next type of cleavage that we're going to learn is heterolytic cleavage. Heterolytic cleavage is the case where two shared electrons of the covalent bond or the bonding electrons are split unequally between the two atoms. Okay, where the electrons are being transferred to more electronegative atom. So in this case, it will occur in a polar bond involving atoms of different electronegativity. So what happens is that we will form cation and anion. Cation means that the atom contains positive charge, whereas anion is where the atom contains negative charge. Okay, so as we can see here we have carbocation. Carbocation is where our carbon containing positive ion, whereas if the carbon containing negative ion, we call it as carbanion. Okay, carbon with a negative sign. Okay. Carbon and bromine means that this bond is a polar bond. Okay, why? Because it consists of different atoms. So carbon is actually atom in group 14, whereas bromine is in group 17. Okay, so group 17 is more electronegative than carbon. So what happened here? This one, it will be not split equally. So the electron will be transferred to more electronegative atom. So how do we know which one is the more electronegative atom? Okay, please remember that the electronegativity increase from group 1 until group 17. So again, what is meant by electronegative? Electronegative means that is the ability of the atom to attract electron. Okay. So the higher the number of the valence electron, the higher the ability to attract electron to itself. So here, carbon have only 4 valence electron, where bromine have 7 valence electron. So bromine needs only 1 more electron to achieve octet. So actually bromine have higher electronegativity. So that's why for these 2 electron, it will be transferred to the bromine atom. So what happened when it is being transferred to bromine? Again, it means that carbon donate 1 electron in there, so it will have positive charge. Whereas bromine accept 1 electron from carbon, hence we will have a negative charge. Because the carbon containing positive charge, the name is carbocation. That is for the heterolytic cleavage of carbon-bromine. So what about heterolytic cleavage of carbon and lithium? So again, carbon is group 14 while lithium is group 1. So between group 1 and group 14, okay, group 14 in the middle here, it will have the higher electronegativity. So when the 2 electron, when this bond undergo heterolytic cleavage, the electron will be transferred to carbon. Okay, so here it means that the lithium will donate 1 of the electron towards carbon. So that's why carbon will have negative charge and lithium will be the one that have positive charge because it has donated 1 electron. Okay, so where the carbon have negative charge attached to it, we call it as carbanion. Okay, and this case we're going to use full-headed arrows because for this case 2 electrons are being transferred. Okay, so that is what you have to learn about homolytic cleavage and heterolytic cleavage. Okay, now we're going to learn more about the product form once the atoms or the bonds undergo homolytic or heterolytic cleavage. First, we're going to start with radical. Okay, so what is radical? Radical is a very reactive species with an unpaired electron. And it is formed in homolytic cleavage. Okay, so why is radical is very reactive? Because it seeks for an electron to complete its octet. So again, actually for each the chlorine here, chlorine contains 7 electron each. Okay, so when it bonded with each other, so each of the chlorine already achieve octet. However, when it's reacted with UV, it will undergo homolytic cleavage. Again, chlorine haven't achieved octet. So it needs only 1 more electron to achieve octet. So that's why it is very reactive. Now is for carbocation. Carbocation is a very reactive species with a positive charge on carbon atom. And for the carbocation, it is formed in heterolytic cleavage. So again, what would happen is that once the electron transferred to more electronegative atom, or the carbon donates the electron towards the more electronegative atom, hence the carbon will have less 1 electron. Okay, or it has donated the electron, so that's why the carbon have positive positive charge attached to it. Okay, but now instead of we calling as cation, we call it as carbocation. Now let's look for the example on page 17. So here it mentioned to draw the products of homolytic or heterolytic cleavage of each indicated bond. Okay, classify each carbon reactive intermediate as carbon free radical or carbocation. Okay, so let us look for example A. Example A asks for the homolytic of carbon-hydrogen bond. Again, so for the case of homolytic, it means that the electrons are being split equally. So when it is being split equally, okay, what we're going to draw is we're going to draw it this bond again. So what happened to the homolytic cleavage? Okay, homolytic cleavage mentioned that the electrons are being split equally. So first we're going to show one of the electron here is being shared to the hydrogen. So we're going to draw the arrow, okay, the curve, and then half-headed. You cannot draw it this way. Cannot. This is full-headed. We want only the half of it. Okay, so one is for hydrogen, another one is for carbon. Okay. Okay, so what happened to the product? So we're just gonna redraw this again. Okay, but now we have to draw the dot here. Okay, and then since it is being divided, so then we have to show lah that it is separate plus with hydrogen. Okay, so and then the question did ask to determine whether it's carbon-free radical or carbocation. Okay, carbocation means that the carbon has positive charge on it. Okay, free radical means that we have unpaired electron. So this is what we call as carbon-free radical. That is for example A. Example B asks us to draw the heterolytic cleavage of the carbon OH bond. Okay, again, I'm just going to redraw this again. But then, for the case of heterolytic, it is being split unequally. So, it means that rather than one will follow carbon, one will follow oxygen. What will happen here is that both of the electron will be moving towards only one atom. But which atom? Again, it will be towards more electronegative atom. So, I'm just going to add in the notes here. So here we have between carbon and oxygen. So which one is more electronegative? So this is actually a bit of revision of what you have learned in semester 1. So for period 2, okay, the order of electronegativity increase from carbon, nitrogen, oxygen, fluorine. Senaf. Okay. So which one is more higher? So oxygen is has the higher electronegativity. Okay, because why? The oxygen here is actually group 16, whereas the carbon is group 14. So again, electronegativity increase from group 1 until group 17. Okay, so what happened here is that the 2 electron here, I'm just going to draw 2 electron here. Okay, is being transferred to the oxygen. So what happened? Okay, there is no bond here anymore. Okay, so what will be the product again? So now the carbon has no electron since this electron also follow oxygen. Okay, assume that it has donated the electrons with the oxygen. Hence, the carbon will have a positive sign. Okay, plus with, since OH, okay, will accept 2 of the electrons towards itself. Hence, the OH will have a negative sign. Okay, so and then we have to label what is this. Is it a carbon-free radical or carbocation? Since it has positive charge on carbon, hence this is carbocation. Okay, actually we have to show the heterolytic cleavage. Okay, just now I showed for the case of homolytic, the electrons will be split equally. This one is not being split equally, all of it will follow oxygen. Hence, we have to show that the electron will be moving towards oxygen itself. Okay, so please add in this arrow. Again, why? Because these 2 electron is going to the oxygen atom. So that is for the examples. Okay, so we have learned about radical and carbocation. Okay, next we're going to learn that the radical and carbocation can be classified as primary, secondary, and tertiary according to the number of alkyl or CH3 group that are bonded to them. Okay, so again, if it's primary, means that primary radical means that it is attached to only one carbon. If it's secondary, it means that it is attached to 2. Tertiary means that it has 3 carbon attached to it. For the case of metal, it means that it does not have any carbon except the one that has the radical itself lah. Okay, the same goes for the carbocation. But then here, it mentioned that from metal to primary, primary to secondary, secondary to tertiary, we have increasing stability of radical. The same goes for the carbocation. It increasing from metal to primary, to secondary, and to tertiary. Okay, why? So here it mentioned that radical and carbocation is a poor electron species. Again, radical, it actually because it contain unpaired electron. While carbocation, because it has donated the 2 electron towards other atom. So right now, it has less electron lah. So that's why we call it as poor electron species. While alkyl group R, okay, again R means that any carbon, So it could be CH3, it could be CH2, CH3, any of the carbon itself lah. Okay, so here it mentioned that alkyl group or carbon itself here is electron donating group. So what does it mean is that this alkyl group will donate the electron. It will increase the electron. Here, electron donating group, EDG, will increase the electron density to the carbon. So what happens? So when the EDG increase electron density to the carbon, EDG will increase the stability of free radical and carbocation. Hence, the greater the number of alkyl group on the carbon atom, okay, the higher the stability of radical or carbocation. Okay, so assume it like this. Okay, bayangkanlah. For example, sekarang ni radical and carbocation ni is poor. Macam kita lah, sekarang ni kita miskin, tak ada duit. So what happen? Sekarang ni pula, alkyl group ni is electron donating group. Kiranya dia ni yang suka donate. So what happens? So assume macam kita ada sugar daddy lah. Setiap R ni adalah sugar daddy kita. Ataupun nak kata every R ni is every uncle that we have. Ataupun any family members yang suka bagi duit dekat kita. So the same goes for the case of radical and carbocation. For example of primary carbocation ni, okay, bayangkan dia ni miskin. Tapi yang ini dia ada seorang je. Satu je family member dia. Ada satu je uncle yang suka bagi duit dekat dia. So dia kira dah stabil lah. Tapi ada lagi seorang ni, ada dua pula tu uncle yang suka donate dekat dia. Ataupun ada dua sugar daddy yang boleh bagi dia duit. So dia lagi stabil lagi daripada someone yang ada only one. Tapi sebenarnya yang paling stable is actually the one with the 3 electron donating group, with the 3 uncle ataupun 3 sugar daddy tu. Okay, again why? Because the radical and carbocation is poor, while the R itself is rich. Bukan sahaja dia kaya, dia pun suka donate. Okay, so that's why the greater the number of alkyl group, the higher the stability of radical and carbocation. Okay, so now let's look for the examples itself. So number 1, arrange the following carbocation in order of increasing stability. So for example, A here we have 1, 2, 3, 4 structure. Before we arrange it in order of increasing stability, first we're going to determine either it's tertiary carbocation, secondary, primary or methyl. Methyl carbocation, okay. So if we have CH3, it means that the name is methyl. Where for the case of CH4, just gonna add, if CH4, the name is methane. Okay, but then this one cannot be called as methane because this is not alkane. So if we have CH3, it means that the name is methyl or methyl. Okay, so let us label. Okay, what do we have here? For structure 1, again, we refer back to the carbocation. Okay, so for this one, the carbocation only attached to one carbon. Hence, number 1 is primary carbocation. Okay, the second one, okay, the carbocation attached to 3. 1, 2, 3. So this is tertiary carbocation. Okay, this carbon, number 3, it does not attach to any of the carbon. Hence, this is our methyl or methyl carbocation. Okay, and then the fourth structure, this one attached to only 2. So it is secondary carbocation. Okay, so how do we arrange it? Again, lagi banyak carbon, lagi banyak uncle, lagi banyak sugar daddy dia, lagilah stable. Okay, so for the arrangement, so the least stable is number 3. Okay, because it has no carbon attached to it. Okay, next is structure. Okay, structure number 1. Okay, next is structure number 4. And then structure number 2. Okay, just to be safe, just draw an arrow and write down increasing stability. Next, we're going to look for the case of B. Okay, so again, structure number 1 here is actually secondary. Structure number 2 here, this carbocation attached to 1, 2, 3. So this is tertiary. And then number 3 again is methyl or methyl. Okay, so how about the arrangement? Arrangement will be number 3. Okay, and then number 1 followed by number 2. Okay, and then just don't forget to write down the increasing stability. Okay, so that is for number 1. Okay, number 2 mentioned that arrange the following carbon-free radical in order of decreasing stability. So right now they nak from more stable to less stable. But then again, let us arrange for the classification first. Okay, this one attached to 1, so this one is primary. Structure number 2 have no carbon, so it is methyl. Okay, structure number 3 attached to 1, 2, 3. So this is our tertiary radical, and structure number 4 attached to 1, 2. So it is attached to 2. So it will be a secondary free radical. So again, arrangement dia decreasing from the most stable. The most stable yang lagi banyak uncle ataupun lagi banyak sugar daddy dia lah. Okay, the most stable adalah 3. Okay, lesser than structure 3 is structure 4 sebab dia ada 2. Okay, and then structure 1 sebab ada 1 je. And then structure 2 is the least stable sebab langsung tak ada uncle ataupun sugar daddy dia. So right now we're going to write down decreasing. Again, for example B, structure 1 is tertiary. Structure 2 is methyl or methyl radical. Structure 3 is primary. Structure 4 is secondary. Again, we want in terms of decreasing from most stable to the least stable. Yang paling banyak uncle ke yang paling sikit ataupun langsung tak ada. So which means the arrangement will be number 1 first. Okay, and then number 4. Okay, and then number 3. And then the least stable is number 2. Okay, don't forget to write down the arrow. And then label it as decreasing stability. Okay, so that is all for this video.